Hello, my name is Grant Likely. I am here with Peter and Pekka, and we're all members of the Linaro Edge Group, or LEDGE, the steering committee at Linaro. And so we're here to talk a little bit about what LEDGE is and why it is important. So first, I'd like to let both Peter and Pekka introduce themselves. So Peter, can you say a bit about who you are?
Hi, I'm Peter Robinson. I'm the principal IoT architect at Red Hat. I deal with everything around the Linux platform in context of IoT and edge computing.
Hello, my name is Pekka Varis. I'm with Texas Instruments Citara processors. I'm a senior member technical staff looking at, for example, networking.
Great, thank you guys. Can you tell me a bit about what LEDGE is?
The Edge Working Group, or LEDGE as it's nicknamed, is a group of companies that are interested in edge computing, fog computing, and various other technologies around Internet of Things and, connectivity and processing and certain sort of areas of that, such as industrial IoT and automotive and various other bits and pieces, and focus on low-level technologies enabling edge computing.
Each of your companies has joined the LEDGE group. Why is LEDGE important for your company?
Working with a number of ARM partners across the edge ecosystem is important. The ability to cross-collaborate with the likes of TI and other such companies from silicon all the way up through the Linux software stack, where Red Hat is obviously focused, and various other parts, so sensors, actuators, various other bits and pieces, and those components, and standardizing on ways to deal with that. So our customers that want to run a piece of software, all the value that Red Hat Enterprise Linux provides in terms of security updates and lifecycle and things like that, the ability to run it across a wide range of pieces of hardware in the ARM ecosystem, but be able to talk to all those different things, all the different sort of wireless protocols and wired protocols that are used in automotive and industry and various other bits and pieces, and sensors and other such things in a standardized manner, so that, because ultimately I speak to customers and they have hundreds of use cases, and you can't get one device or one vendor that fits all those hundreds of use cases, but they want a standard platform to run across all those use cases, so they don't have to have individual teams running individual stacks for all the different use cases. And so the ability to be able to collaborate with the likes of TI and the other LEDGE members on standardizing that, so the OS boots in the same way as they would expect on a PC or a server, and the special interfaces such as CAN or time-sensitive networking, Ethernet, and various other bits and pieces just work the same across any of the vendors, is critically important to the industry, so that you don't end up with thousands and thousands of different standards. So Linaro LEDGE provides a fantastic sort of means of cross-collaboration where, TI and ST are working together alongside Red Hat, even though as a whole they may be competitors. So it's a little bit sort of like the way the industry gathered around the OpenStack Foundation for general compute. I see Linaro Edge Group as a similar sort of thing for Edge, where competitors and partners and what have you can all collaborate as a group together to improve the industry as a whole.
Yeah, I pretty much completely agree. But it's like the whole value of Linux to our customers is that it's a collaborative effort. It's stronger than these individual RTOSes that everybody would be building in silos.
Right.
So it's like we don't want to build different plumbing for different buildings. It's basically we want the infrastructure that everybody's going to need, and we want it to be robust, and that's why you want to collaborate, and that's why our customers expect that's what they expect from Linux. They don't want your own secret sauce. They want the open source.
So what problems is Ledge solving right now?
So I'd maybe take one example for me is the time-sensitive networking, which is an extension of IEEE standard Ethernet that's kind of in the process of maybe replacing some of the legacy proprietary industrial field buses. So it standardizes the deterministic Ethernet at the local area network level. So kind of on your factory floor, your conveyor belt, the boxes controlling that, they are able to talk to each other in a deterministic manner. But at the same time, there's pressure from adapting these kind of industry 4.0 applications that require sophisticated software stacks, security features, they require Pythons and so on, which are complicated software features, but they are all of it is available and well supported in Linux. So we want to combine those, and that's a perfect example of where Linaro Ledge comes in.
Right.
The sort of things that Red Hat are interested in are things like universal provisioning, and so working with the ARM ecosystem on a single way to securely provision a device, a single way to boot a device. The traditional ARM embedded world had numerous different ways of booting Linux, depending on the SoC and even the board. They were all very, like each time it was an artisanal creation, and nothing was the same. And that is not a way to support, millions or even billions of devices connected across the internet, because there's no way to do standardized security audit, no way to securely connect. And our customers don't want to have to run 10 different provisioning platforms to support 1 million devices. They want one provisioning platform, and they want to be able to do the same provisioning process, because if you need to deploy millions of devices, you will have them shipped off around the world, and you want to be able to train your staff one way to do it. You don't need to say, if the device looks like this, do this, else do this, because that's complicated. And each time you add more complication into the process, it's more likely to be mistaken or broken or cause problems and things like that. So provisioning and standardized ways of doing things like that is very important. And not just standardized ways, but open standards, open implementations, open platforms, so that it doesn't just benefit one or two companies, it benefits the entire ecosystem.
Right. So, Pekka, you've talked about time-sensitive networking, and Peter, you've talked about the large deployments. Things like time-sensitive networkings or industrial controllers has historically been very embedded, very siloed use cases. Do you see a transformation happening right now within areas like industrial IoT rollouts or the custom embedded engineering that in years before it would be again all the custom engineering?
Basically, yes. I mean, there's that. Yes. So there's it's kind of a overhyped word, but the Industry 4.0 and the pressure to kind of adapt all everything from cloud connectivity to kind of all the goodies of that might have been already adapted in the enterprise world, pushing it down to these deep embedded systems.
Right.
But we have to still make sure that the determinism and solving the physical world problems are taken care of, and that's really the difference or the nuance that Ledge brings in.
Yes, over the 3 years I've been in this role at Red Hat, I've spoken to dozens or even hundreds of customers, and they're seeing in oil and gas industry, automotive industry, rail, logistics, all sorts of industries where they're moving from systems that are quite often traditionally PLCs designed to do one role and, take sensors and react in a particular real-time manner. And they're moving to more complex operating systems, more powerful devices, the ability to do machine learning and more automated control or quicker control. But as a result of that, they're being connected to networks and things like that. And you see these absolute disaster stories where, 100,000 cameras, get compromised and take down the internet across the US and things like that. And you speak to these customers and they're like, we don't want to be on the news like that. Or if a factory gets taken offline, it costs them millions of dollars. And so they're moving from devices that used to be quite often install and forget to, oh my, we need to patch this every quarter, or we need to have a response policy, or how do we deal with security and vulnerabilities? How do we monitor whether our factory is getting attacked or not? And so these are the discussions, and areas of these businesses have never had to deal with this stuff. And so they're going and speaking to their IT departments, and their IT departments are like, well, we have policies and processes for dealing with this on the servers, but how do we scale this to 1 million devices? Because they may have 10,000 servers, but they may end up with 1 million devices in the field, and one of the interesting things I've found with a few customers is security is of high concern, but part of the issue is, so with traditional Red Hat Linux in the data center, you have the physical security of the data center, you have access control, you have, ways, there's only certain people in the organization that can physically or virtually access those servers. And so they have policies and various other bits and pieces in place for that. And so things like whether people can put something in a USB port or not are defined by whether that person can physically access that area of the data center. And the people that have access to the data center have audits against them and contracts and various other bits and pieces. If you go and take a device that is running basically the same operating system and strap it to a light pole in the street or something else, you're taking away the physical security of the data center. And so the software security of the stack, using things like secure boot and TPMs to attest that the OS has been compromised or not, become an order of magnitude more important than performance and various other bits and pieces, because you don't have that physical security that you do of a data center. And it's interesting because there's areas in Linux where the functionality has been there for some time, but it hasn't been well used because there hasn't really been a huge demand for it. And so it's interesting looking at things like the integrity measurement architecture within the Linux kernel, TPMs and stuff like that. You're suddenly getting huge amount more interest. And the fact of the matter is our data center customers want it as well, but maybe not as much as the latest version of Kubernetes and stuff like that, where I'm seeing it be flipped on the head. It's like, we must have this, we must have this, we must have this. And it's interesting discussing with some of the hardware vendors, because if you actually go and look at a lot of the Industry 4.0 focused devices at the moment, do they have a TPM2 on board? Most of them do not. Mm-hmm. And it's interesting because they're like, oh. And so, while things are a lot like the data center, there's a whole lot of things that aren't like the data center. And it's interesting seeing how companies are starting to realize this and deal with those shifts.
Right,
yes.
right.
Yeah, I'd maybe add that, but for example, the networking security is at a very nice level in enterprise world. And that's something I think we kind of want to bring to the embedded. And that's kind of one of the reasons why Linux is relevant. Is that why you no longer can do your bare metal main loop thingy controlling the robot.
Mhm.
You're suddenly plugged into the internet. You're no longer in your proprietary bus architecture.
Right.
So what the only secure networking that's out there is available in Linux.
Mhm.
Ledge has had a lot of involvement at this point from operating system vendors, silicon vendors. ARM has been involved. What do you think? Do you think it would be valuable for Tier 1 ISVs to be involved with Ledge?
Certainly. I mean, ultimately, Edge is a huge category, and at the moment, you know, getting the hardware in place and getting an operating system on it and running doesn't actually make it a particularly useful device. You need the ISV stacks on top of that, and there are a number of them out there in the industry, and the ability to be able to run and integrate and make sure that we have the lower layers correct by running, you know, popular tier 1 ISV stacks on top of that, I think is a critical part of the process, because until we get an end-to-end product stack in place, we can't verify that everything we're doing is correct. So having a full loop in the software stack and having cross-collaboration with those companies as well, I believe is a critical part of Ledge, and it will ultimately provide better or more value to the companies that are currently involved, and no doubt countless value to the new members that would come on board to join in the process.
I think in addition to the value, there'll be a lot of value in getting basically like in the use case prioritization of what's the kind of first thing to look at. I think we got a whole bunch of ideas, but like what's the first set of things to solve, and maybe also bring in some, so often at least in the embedded systems, there's like you need to solve a physical world problem, but you don't want to kind of over-engineer it. So you want to be able to hit the correct case without having like solving all the problems in the world at the same time. So I think that prioritization and finding that's where I'd be happy to see participation.
Right. Great. Well, thank you very much to both of you for taking the time to talk to me today.
Thank you, Grant.
Thanks, Grant.